We have always been told that sapiens were the superior species, but in the dead of night, we were completely outclassed. New neurological dissections supposedly reveal that Neanderthal brains were hardwired for low-light precision. The claim says they prioritized raw visual processing over tactical cooperation. Today, we are diving deep into the biology of their massive eye sockets. We want to know how they may have dominated the dark. That opening sounds explosive. It also contains a trap. No scientist has ever dissected a living Neanderthal brain. No fossil can tell us exactly what a Neanderthal saw after sunset. No archaeological site comes with a convenient label that says night hunt at 11:47. One rhinoceros. Terrible decision. What we do have are skulls. We have eye sockets. We have body proportions. We have hunting injuries. We have weapons. We have animal bones. We have genetics. And we have one controversial scientific hypothesis. Together, these clues allow us to ask a much more interesting question. Were Neanderthals truly the ultimate night hunters? Or have we taken one anatomical clue and turned it into prehistoric night vision goggles? Imagine waking in the middle of the night inside your modern home. The electricity is out. Your bedroom door closes behind you. The hallway disappears. You freeze. You extend both arms like a confused zombie. You shuffle forward. You try to remember whether the chair is 2 steps away or whether it is directly in front of your knee. 10 seconds later, your phone is in your hand. Flashlight on. Problem solved. You live in a building with smooth floors. The doors are locked. There are no cave lions. There is almost no chance that a mammoth will trample you. Yet without artificial light, you feel instantly vulnerable. Now remove the phone. Remove the walls. Remove the streetlights. Remove the glass windows. Remove the emergency services. Remove every object designed to make darkness less dangerous. Replace your hallway with an Ice Age forest. The temperature is below freezing. Fog sits between the trees. Something heavy is breathing beyond the firelight. The only thing separating you from it is your ability to detect movement before it detects you. This was the world occupied by Neanderthals for hundreds of thousands of years. They lived across western Eurasia. Many of these regions had short winter days. They had dim light. They had heavy clouds. They had snow glare. They also had long periods of darkness. Their skulls contained one of the most dramatic features in human evolution: large orbital cavities. These are the bony chambers that held their eyes. A widely discussed study from 2013 compared Neanderthal skulls with early modern human skulls. The researchers found that Neanderthal eye sockets were larger on average. That does not mean their eyeballs were exactly 20% larger. It does not tell us how many rod cells they possessed. It does not prove that they saw a moonless forest as clearly as you see a supermarket aisle. But orbit size is not meaningless. Across living primates, eye size is influenced by body size. It is also influenced by visual demands, and it can be influenced by the light environment. Larger visual organs may collect more light, but true night vision depends on much more than size. It depends on the retina. It depends on the lens. It depends on the pupil. It depends on neural wiring. It depends on soft tissues that never fossilize. The Neanderthal skull gives us the outside of the camera. The internal sensor is missing. This is where the story becomes controversial. The researchers from 2013 argued that Neanderthals had larger bodies and larger visual systems. Those systems may have required more brain tissue for body control and visual processing. After accounting for those demands, the researchers proposed another possibility. Less neural capacity may have remained for the expanded social networks that helped some Homo sapiens groups survive environmental instability. It is a powerful idea. Large eyes, large body, more neurological hardware for vision and movement, smaller, effective social networks. One evolutionary trade-off may help explain why one human lineage disappeared while another expanded. But this is still a hypothesis built from indirect measurements. A fossil skull does not preserve a map of every neuron. The back of a brain case cannot reveal the size of an occipital lobe with the certainty of a modern brain scan. Larger eye sockets do not automatically mean superior night vision. So let us stop treating the theory like a solved mystery. Let us test what it might mean in the real world. Picture a Neanderthal hunting group 50,000 years ago. The sun has already vanished. A weak moon appears and disappears behind clouds. Snow reflects a small amount of available light. The hunters are not walking through absolute darkness. Human eyes cannot work where no photons exist. They are moving through low light. That difference matters. Moonlight creates useful information. Starlight creates useful information. Snow reflection creates useful information. Open terrain creates silhouettes against the horizon. A person with better low-light sensitivity might detect movement sooner. A broad animal shape may appear before its details. A moving leg may separate from a stationary tree. A patch of shadow may reveal itself as a predator when it blinks. The Neanderthal at the front suddenly stops. Nobody speaks. He has noticed a branch moving against the wind. The others follow his gaze. Beyond the trees, several deer are resting near a slope. This scene is a reconstruction. It is not a documented event. But the behavior it requires is not fantasy. Neanderthals successfully hunted large animals. At Neumarkt Nord in Germany, researchers found damage on fallow deer bones. The wounds were consistent with close-range thrusting spears. A cave lion from Siegsdorf appears to have been killed with a wooden spear. The strike was delivered at close range. At Leringen, a long yew spear was found with the remains of a straight-tusked elephant. A new analysis in 2026 strengthened the case that Neanderthals gained early access to the fresh carcass. They then exploited it extensively. These were not helpless scavengers waiting for predators to finish eating. They could organize dangerous hunts. But did they perform those hunts at night? We do not know. There is no direct archaeological clock. A spear wound looks the same at noon. It looks the same at dusk. It looks the same under a bright moon. The most responsible version of the night hunter story is not that Neanderthals definitely ruled the darkness. The responsible version is more careful. Their anatomy and environment make greater reliance on dim light activity plausible. But direct proof is missing. Even if their vision offered an advantage, night hunting would not have been a solo superpower. A large animal does not become harmless because the sun goes down. Darkness hides the hunter. It also hides holes. It hides cliffs. It hides branches. It hides other predators. It hides the exact location of the animal's horns. Imagine approaching a resting deer. One hunter moves from downwind. Another blocks the easiest escape route. A third waits near the slope. The animal suddenly rises. The quiet hunt becomes several hundred kilograms of panic moving through limited visibility. This is not a scene where one visual genius defeats nature alone. Vision must work with planning. It must work with weapon skill. It must work with communication. It must work with cooperation. Another claim in the night hunter theory also needs care. Some people say Neanderthals prioritized visual processing instead of tactical cooperation. That can sound as if they traded friendship for enormous eyes. The archaeological and genetic evidence does not support that cartoon. Close-range hunting requires coordination. Some injured Neanderthals survived long enough for serious wounds to heal. That suggests other people provided food. They may also have provided protection. Neanderthals made complex tools. They controlled fire. They processed carcasses. They moved raw materials. They maintained knowledge across generations. A genetic study from 2022 examined Neanderthals from Chagarskaya Cave. It found a small local community with close relatives. The group included a father and daughter. The same study also found another important pattern. Women may have moved between communities. That is not complete isolation. It is a social system. The system may have been small. It may have been vulnerable. It may have differed from the wider networks of some later Homo sapiens populations, but it was still connected. So why did Neanderthals have such large eye sockets? Latitude remains one serious possibility. Modern primates that live farther from the equator experience different light conditions. The study from 2013 linked larger Neanderthal visual systems with higher latitude environments. But there are other factors. Neanderthals had large bodies for their height. Their faces projected forward. Their skulls developed differently from ours. Orbit size may reflect several anatomical pressures at once. It may not represent one single adaptation for night hunting. Evolution rarely labels one feature with one purpose. A broad nose is not only a heater. A brow ridge is not a helmet. A large orbit is not automatically a pair of military night vision goggles. Real biology is messier and much more interesting. Now return to the moonlit hunt. The deer begin moving. The Neanderthals do not all carry one standardized weapon. Some wooden spears may have been used for thrusting. Others may have been thrown. Experiments with Pleistocene-style wooden spears show that hand-thrown weapons can travel effectively. Newer archaeological work also warns against treating Neanderthal hunting as exclusively close range. One hunter throws. The spear misses. It strikes the ground. The herd runs toward the slope. A second hunter moves into position. The animal turns away from him. It moves toward the narrow route selected by the group. The third hunter closes the distance. The final strike happens at close range. This is not an animal wrestling contest. It is cooperative control of movement. If low-light vision helped, then it supported the plan. It did not replace the plan. The successful hunters returned to camp before sunrise. The carcass must be butchered. The meat must be shared. Fuel must be collected. Tools must be repaired. Children must be fed. Information about the herd must be remembered. Where were the animals? Which path did they take? Which hunter saw them first? Which slope trapped them? What changed in the wind? Vision may find the animal. Culture keeps the lesson. This is the central twist. The most fascinating Neanderthal advantage may not have been perfect vision in darkness. It may have been the combination of several things. A physically demanding body, strong visual attention, intimate knowledge of the landscape, small group cooperation, and an environment that punished mistakes immediately. That is already extraordinary. We do not need to give them supernatural eyes, but the story still has a cost. Neanderthals appear to have lived at lower population densities than Homo sapiens. Some local communities were small. Small populations are vulnerable. A bad winter can reduce food. An accident can remove an experienced hunter. Disease can move through relatives. Low birth rates can create a demographic trap. A local tradition can disappear when only a few people know it. Homo sapiens did not need to be stronger in every body. They did not need to be better in every sense. They needed resilience at a larger scale. Wider social connections can move food. They can move stone. They can move partners. They can move information. They can move assistance across landscapes. But even this contrast must not become another myth. Not every Neanderthal community was equally isolated. Not every Homo sapiens group maintained enormous alliances. Neanderthals moved raw materials. They exchanged genes between communities. They occupied a huge territory for a very long time. Their disappearance around 40,000 years ago was probably not caused by one smaller social brain losing one final contest. Climate instability mattered. Low population numbers mattered. Competition may have mattered. Disease may have mattered. Chance mattered. Interbreeding mattered. Some Neanderthals did not simply vanish. They became ancestors. When Homo sapiens expanded into Eurasia, the two populations met. They also had children together. Today, many people with ancestry outside Africa carry roughly 1 to 2% Neanderthal DNA on average. Some populations within Africa also carry smaller amounts. Later human migrations carried that ancestry back into Africa. These inherited fragments influence several biological systems. They influence immunity. They influence skin biology. They influence pain sensitivity. They influence metabolism. They also influence circadian timing. But there is no known Neanderthal night vision switch hiding inside your genome. Your inability to cross a dark hallway without your phone is not proof that evolution deleted a prehistoric flashlight from your eyes. Still, the circadian connection gives the story a final echo. Neanderthals lived for thousands of generations under Eurasian cycles of daylight and darkness. Some inherited variants from archaic humans affect how modern bodies respond to daily light cycles. They may also affect sleep timing. That does not make you a night hunter. It makes you the carrier of a complicated evolutionary archive. Now return to your dark hallway. Your phone battery is almost empty. The light suddenly switches off. For 1 second, you see nothing. Then, faint shapes begin to emerge. The doorframe, the edge of the wall, a window reflecting a little city light. Your eyes adjust, but they adjust slowly. You move carefully. Somewhere in your ancestry is a lineage that survived landscapes where darkness could hide prey. It could hide predators. It could hide cliffs. It could hide strangers. It could also hide opportunity. We're Neanderthals, evolution's ultimate night hunters. The fossils cannot give us a final yes. Their larger eye sockets support the idea that vision placed unusual demands on their biology. Their high-latitude lives made dim light performance valuable. Their hunting record proves that they could coordinate dangerous encounters with large animals. But we cannot prove that they regularly stalked megafauna in the dead of night. We cannot prove that they saw perfectly in darkness. We cannot prove that they sacrificed tactical cooperation to build a giant visual cortex. The honest conclusion is less absolute. It is also more powerful. Neanderthals may have been better adapted than us to visually demanding low-light environments in Eurasia. If so, then darkness was not a magical kingdom that they completely controlled. It was another hostile condition that they learned to exploit. They did not dominate the night because one anatomical feature turned them into superheroes. They survived because their eyes worked with their bodies. Their bodies worked with their weapons. Their weapons worked with memory. And every individual worked with companions. The next time you activate your phone flashlight to travel 10 safe feet through your own home, remember the figure moving beyond the Ice Age firelight. He is not wearing biological night vision goggles. He is watching the snow. He is reading movement. He is listening to the group behind him, and he is stepping carefully into the dark.